Thank you for following me on Twitter. I'd also like to welcome everyone who has joined me over the past month. Over the last 6 months, there have been 3 reasonably bright supernovae on view for amateur astronomers. 2 in their own Milky Way galaxy, Nova Delphini and Nova Centauri, which were easily visible to the naked eye, and 1 in the nearby galaxy Messier 82, which reached magnitude +10. Therefore, in this month's programme, we take a look at supernova. The word nova is a Latin word that literally means new, as in new star. Strictly speaking, a nova is not a new star at all. What happens is that a formerly very faint star suffers an outburst which makes it flare up many times its normal brilliance. It remains bright for a few days, weeks or perhaps months, and then sinks back to its former obscurity. In the past, there has been some spectacular nova. Most have left fingerprints in the form of nova remnants, which astronomers are studying in great detail. Take a look at these 2 photographs. The Crab Nebula, Messier 1, in the constellation of Taurus the Bull, is the result of a daylight nova that erupted in the year 1054. And here is a view of 3C10, the remains of a nova first observed by Danish astronomer Tycho Brahe in 1572, known as Tycho star. I'll have more to say about these historic supernovae later in the programme. Just as the solar system is a minor part of our galaxy is only a minor part of the whole universe. Our Earth is 93 million miles away from the Sun, and the nearest of the stars, Proxima Centauri, is 24 million miles out. Figures on this scale are exceptional, so astronomers have introduced a yardstick we call the light year. It is based on the velocity of light, which amounts to 186,000 miles per second, and which has been measured with great precision. If a ray of light covers 186,000 miles each second, it will travel roughly 5,880 trillion miles. That's almost 6 million miles in a year. This is the astronomer's light year, so that to convert light years to miles in round numbers, all that you need to do is multiply by 6 million. In metric unit, it amounts to 9.5 trillion kilometres. On this scale, the nearest galaxy, Messier 31, in the constellation of Andromeda, lies 2.2 million light years distant. The star's magnitude is a measure of a star's apparent brightness. The lower the magnitude, the brighter the star. The unaided eye can see stars down to magnitude +6, and the world's largest telescopes will show stars of magnitude +24. Bodies can be brighter than +0.0. The planet Venus can reach -4.4, while Jupiter is currently shining at magnitude -2.1. Therefore, when a nova reaches naked eye visibility, it is a special event. Nova Delphini was discovered by Koichi Itagaki in Japan on the night of August 14, 2013, shining at magnitude +6.8. It had turned nova a few days previous and was getting intrinsically brighter by the hour, reaching maximum magnitude of +4.8 on the night of August 17th, when it was visible to the naked eye. The following day it was officially classified as Nova Del 2013. It is known as Nova Delphini because it lies in the little constellation of Delphinus, the dolphin. The best direction finders are the 3 brilliant stars of the so-called summer triangle: Vega in Lyra, the lyre, Danube in Cygnus, the swan, and Altair in Aquila, the eagle. Delphinus is recognisable as a small haze of faint stars not far from Altair. Members of the American Association of Variable Star Observers then set to work observing Nova Delphini on every available night. Its magnitude slowly fluctuated over time, however it was clearly in decline, reaching magnitude +6 on August 28th and +9 on October 10th. The nova is now coming into view in the morning sky and was last observed to be around magnitude +12. A careful search of photographic plates in the Asiago Plate Archive found what is now believed to be the original white dwarf star that exploded at Nova Delphinus 2013, which was shining at magnitude plus 17. Ulysses Morori and Arnie Hendon of the Concoli Observatory, Budapest, said that the spectrum and variability of the star are in agreement with a white dwarf dominated by the emission from an accretion disk. Therefore, Nova Del 2013 is a Type 1a supernova. Nova Del 2013 is not the first supernova to come into view in the constellation of Delphinus. On the night of 8th July 1967, the well-known British amateur Jed Alcock, who was a schoolmaster by profession, discovered Nova Del HR 1967 above the two variable stars U and EU Delphini. Before its outburst, Nova HR Delphini shone as a dim star of the 12th magnitude. When it flared up, it reached naked eye visibility of magnitude plus 4.5 and fluctuated around this level until May 1968 before slowly fading from view. By January 1970, Nova HR Delphini was at magnitude plus 9. Spectra taken by astronomers at the Lick Observatory between 1972 and 1976 indicate that there is now a nebula with at least two rings of material where Nova HR Delphinus used to be. It is inclined at an angle of 28 degrees. The constellation of Centaurus, the Centaur, is a large prominent constellation of the southern hemisphere which is dominated by the bright star Alpha Centauri. The initial discovery of Nova Centauri 2013 on the night of December 2nd was made by John Search, based at Chatsworth Island in New South Wales, Australia. The preliminary discovery magnitude was plus 5.5, just above naked eye visibility from a good dark sky side. Nothing was visible on an image taken with the same instrument on November 26, 2013, which had a limited magnitude of plus 11. So it appears that the nova flared up relatively quickly by a factor of 10. The nova in Centaurus quickly reached magnitude plus 3.2 on December the 14th, breaking the record of the top 20 brightest nova stars of all time. Soon observatories turned their telescopes towards Nova Centauri and confirmed the discovery, including astronomers of the European Southern Observatory in Chile. Careful analysis shows that the nearest star, located close to the observed coordinates of Nova Centauri, was of magnitude plus 15. The spectrum of Nova Centauri shows that it is slightly different to that of Nova Delphini because it is of a type known as a classical Type 1 nova. Nova not only occur in our own Milky Way galaxy, they also flare up in distant galaxies as well, and so far this year, more than 10 discoveries have been made, all of which have been very faint and out of reach of amateur-sized instruments. Beginning with Nova 2014A, on January the 1st, in NGC 5054, in the constellation of Virgo, this nova brightened to magnitude plus 16.4. One of the most recent nova to be discovered is Nova 2014J, discovered by F.J. Fossey and his students on January the 22nd in Messier 82, shining at magnitude plus 10, which has attracted most attention. It was discovered at University College London. On January the 22nd, astronomers using the Hermes high-resolution spectrograph mounted on the Marquette telescope in La Palma, Spain, obtained a spectrum of Nova 2014J, which confirmed this to be a Type 1a supernova. Amateur astronomers have wasted little time taking photographs of Messier 82 during recent weeks, which lies in the constellation of Ursa Major, the Great Bear. Messier 82, also known as the Cigar Galaxy, is of magnitude plus 8.4 and is the prototype nearby Starburst Galaxy lying 12 million light-years away. The Starburst Galaxy is 5 times more luminous than the whole Milky Way and 100 times more luminous than our galaxy's centre. The starburst activity is thought to be triggered by interreactions with our own galaxy the Milky Way. The advantages of Type 1a supernova in distant galaxies is that they can be used as distance markers to determine just how far away the galaxy lies. By comparing the known luminosity of a nova to its observed brightness, the distance of the object can be computed. These objects of known brightness are termed standard candles. The main difference between a Type 1a nova and that of classical Type 1 comes down to the different chemical elements in the star spectrum and what astronomers call the Chandrasekhar limit. Subramanian Chandrasekhar was an Indian-American astrophysicist who was born on October the 19th, 1910. Together with William A. Fowler, he was awarded the 1983 Nobel Prize for Physics for his mathematical theory of black holes, which was a key discovery that led to the currently accepted theory on the later evolutionary stages of massive stars. He died on August 21st, 1995, and the Chandrasekhar limit is named after him. Most stars we see in the night sky have a companion orbiting around their centre of gravity. In Type 1 and 1a supernova, the main component is a white dwarf. They are very dense. A white dwarf's mass is comparable to that of the Sun, and its volume is comparable to that of the Earth. Its faint luminosity comes from the emission of stored thermal energy. The material in a white dwarf no longer undergoes fusion reactions, so the star has no source of energy, nor is it supported by the heat generated by fusion against gravitational collapse. It is supported only by the pressure of its electrons, causing it to be extremely dense. A teaspoon of white dwarf material will weigh many tons. What happens is that the more massive white dwarf star pulls the material of its larger, weaker companion onto its own atmosphere, creating what astronomers call an accretion disk. Everything is fine until the mass of the white dwarf reaches a critical limit of 1.44 times the mass of the Sun, the Chandrasekhar limit. In a classical 1 nova, the atmosphere of the white dwarf dramatically flares up, although the star is not totally destroyed in the process. In a Type 1a supernova, the white dwarf is completely destroyed. A team of astronomers, led by Dr. Alicia Margarita Soderberg from the Harvard-Smithsonian Center for Astrophysics, announced the discovery of a new type of supernova named Type 1ax in March 2013, which is essentially a mini-supernova. These are in a class of their own and are relatively rare. The team identified 25 examples of a new supernova. None of them appeared in elliptical galaxies, which are filled with old stars. This suggests that Type 1a supernova come from young star systems. To determine what type of supernova is, astronomers turn their telescopes towards the star as soon as it becomes visible and pass its light through a spectrograph that splits it into a rainbow of colours. The spectrum is crossed by black absorption lines that show the chemicals present. From this, they are able to classify the nova into Type 1 and Type 2. Type 1 supernova are further divided into 3 groups of A, B and C, as shown here. Thanks to astrophysicists at the Alliance Center for Astrophysical Thermonuclear Flashes at the University of Chicago, astronomers now have a better understanding of what actually happens to the white dwarf star during a Type 1a supernova explosion. In November 2007, they used a powerful computer to do the necessary calculations. This is what happens to the star. In 1 second, a flame bubble forms inside the white dwarf. This initial bubble measures 10 miles across and rises over 1,200 miles to the surface of the star and breaks through the stellar atmosphere. It then spreads over the white dwarf at more than 3,000 miles per second before it collides with a point on the opposite surface of the star and produces two energetic jets, one moving outwards at 40,000 miles a second, while the other punches its way into the white dwarf, totally destroying it. The temperatures reach 3 billion degrees Fahrenheit during the whole burning phase, but takes less than 3 seconds to complete. So far, we have looked at Type 1 and Type 1a supernova. The Type 2 supernova results from the rapid collapse and violent explosion of a massive star. A star must have at least 8 times and no more than 40 to 50 times the mass of the Sun for this type of explosion to occur. It is distinguished from other types of supernova by the presence of hydrogen in its spectrum. Type 2 supernova are mainly observed in the spiral arms of galaxies and in H2 regions, but not in elliptical galaxies. One of the biggest mysteries in astronomy, how stars blow up in supernova explosions, finally has been unravelled with the help of NASA's Nuclear Spectroscopic Telescope Array, NuSTAR. The High Energy X-ray Observatory has created the first map of radioactive material in a supernova remnant. Results from a remnant named Cassiopeia A reveal how shock waves literally rip apart a massive dying star. The explosion which gave birth to the compact radio source Cassiopeia A occurred about the year 1715. It remained unobserved primarily because this supernova was very weak in its optical display. Stars are spherical balls of gas, and so you might think that when they embryolize and explode, the explosion would look like a uniform ball expanding out with great power, said Fiona Harrison, the principal investigator of NuSTAR at the California Institute of Technology, Caltech, in Pasadena. Our new results show how the explosion's heart or engine is distorted, possibly because the inner regions literally slosh around before detonating. The most recent supernova of this type flared up relatively close. Supernova 1987A was discovered by Ian Shelton and Oscar Gulhard at the Las Campanas Observatory in Chile on February 24, 1987. It was situated in the Large Magellanic Cloud. Our Milky Way is a barred spiral galaxy containing about 100 million stars. It is 100,000 light years in length and 10,000 light years in thickness, measured through its central nucleus. It has two nearby satellite galaxy companions, visible with the naked eye in the southern hemisphere, that we call the Magellanic Clouds. The Small Magellanic Cloud is a dwarf galaxy. It has a diameter of about 7,000 light years and contains several hundred million stars. The Large Magellanic Cloud lies at a distance of slightly less than 163,000 light years and has a diameter of about 14,000 light years. The star which exploded would originally have been around 20 times the mass of the Sun, but in the latter stages of its life it lost around a third of its mass into a giant cloud. Eventually, the aging star could no longer support its own weight, and on the 23rd of February 1987, astronomers saw it brighten dramatically as it collapsed in a violent supernova. The explosion resulting from the collapsing star is one of the most violent events in the universe, and this event was no different. The supernova glowed with a brightness of 100 million suns for around a month, while most of the material that made up the star was blown outwards at immense speeds. The resulting shock wave energized a ring of material in a disk of gas and dust around the star and is still travelling outwards at speeds of up to 13 million miles per second. The pulse of light from the supernova lit up a ring of material around a light year across, dozens of times the size of our solar system. This material glows in visible and ultraviolet light as well as in X-rays. Small amounts of dust in the ring were warmed to a temperature of minus 100 Celsius, and this has previously been seen glowing faintly in infrared light. There are other red giant stars in our own Milky Way, but are unstable and could go supernova at any time. These include Betelgeuse in Orion, the Hunter, and Antares in the constellation of Scorpio, the Scorpion. Then we come to hypernova. Much more massive stars like Eta Carina and VY Canis Majoris will eventually become hypernova. Eta Carina is a stellar system in the constellation of Carina, the Keel, about 8,000 light years from the Sun. The system contains at least 2 stars, of which the primary is a luminous blue variable that initially had around 150 solar masses. VY Canis Majoris is a red hypergiant in the constellation of Canis Major, the Great Dog. It is one of the largest known stars by radius and also one of the most luminous of its type. It is approximately 1,420 times bigger than our Sun and lies 3,000 light years from the Earth. Now that we have explored our modern understanding of what supernovae are, it will be of interest to consider some of the more historic nova recorded by skywatchers since the 2nd century AD. The 2nd century is a period from 101 to 200 in accordance with the Julian calendar. Stories of nova go back through many centuries, and it has been suggested that Hipparchus, the great Greek astronomer of antiquity, drew up his famous star catalogue after his attention had been drawn to the skies by a brilliant nova. The Sun will never become a supernova, it is not heavy enough, and in the course of time it will come to a quieter end. Not many supernovae have been seen in our galaxy in recorded times, though we have observed plenty in outer galaxies, because a supernova is so powerful. It can be seen over a vast range. The only galactic supernovas about which we have any definite information are those of AD 185, 1006, 1054, 1572 and 1604. Supernova 185 is the first ever recorded supernova which appeared near the direction of Alpha Centauri between the constellations of Circinus and Centaurus. This great guest star was observed by Chinese astronomers in the Book of La Terre and may have been recorded by Roman literature. It remained visible in the night sky for 8 months. The gaseous shell RCW86 is probably the supernova remnant of this event, which lies at a distance of 9,100 light years. X-ray images from the European Space Agency's XMM Newton Observatory and NASA's Chandra X-ray Observatory are combined here to form the blue and green colours of the picture. The X-rays show the interstellar gas that has been heated to millions of degrees by the passage of a shock wave from the supernova. The second was in the southern constellation of Lupus, the Wolf, and we know little about it. It was discovered between April the 30th and May the 1st, AD 1006. This guest star was described by observers in China, Japan, Iraq, Egypt and Europe, and possibly recorded in North American petroglyphs. It was the brightest stellar event in recorded history, reaching magnitude -7.5, and it lies 7,200 light years distant. The 1054 supernova in Taurus, the Bull, was first observed on the 4th of July, 1054, and lasted for a period of around 2 years. The event was recorded in contemporary Chinese astronomy, and references to it are also found in later 13th century Japanese document and in a document from the Arab world. The 1054 supernova has proved to be of most importance because we can still see its remnants. It was a forerunner of the gas patch called the Crab Nebula, which sends us radio waves as well as X-rays and visible light, and which contains the only neutron star which has been optically identified. Other neutron stars are traceable because of their rapidly varying radio signals. We know them as pulsars. The 1572 supernova was Tycho's star, that is named after the Danish astronomer, and that of 1604 is always associated with the name of Kepler. Tycho had no idea of the true nature of the spectacular newcomer, but at least he could make some precise measurements of it. Using the equipment which he had devised, he checked on the position near the conspicuous W of stars in Cassiopeia. It showed that there was no detectable parallax and concluded it was not some kind of comet or fiery meteor. It did not last indefinitely, and as the weeks went by, it faded noticeably. By December, it was about equal to Jupiter. In March, at the first magnitude. In April and May, it sank to the second magnitude, so that it was comparable to the pole star. The fading went steadily on, and the last sighting of it was made in March 1574. Its colour changed also, and Tycho was not slow to point out the astrological implications. During this period, another bright star blazed out, this time in the constellation of Ophiuchus, the serpent bearer, formerly called Serpentarius. It was first seen on the night of October the 9th, 1604, by a court official named John Bronowski, who was a keen astronomer and who told Kepler about it. Kepler was sceptical, but as soon as the clouds cleared away from the Prague sky on the 17th of October, he saw it for himself. By then, it had already been found elsewhere by other astronomers. It was subsequently named after him because his observations tracked the object for an entire year, and because of his book on the subject entitled On the New Star in Ophiuchus's Foot, Prague 1606. Visible to the naked eye, Kepler's star was brighter at its peak than any other star in the sky, and brighter than all the planets other than Venus, with an apparent magnitude of -2.5. It was visible during the day for over 3 weeks. Today we know that Kepler's star is located 20,000 light years away. Kepler, of course, did not believe the stars to be suns, and he followed Tycho's ideas about the star of 1572. The newcomer was made up of matter from the Milky Way, which gradually dispersed. In his book, De Stella Nova, the same title as Tycho had used, published in 1606, he threw in some astrology. The star indicated the approaching destruction of the Turkish Empire, and so on. Then came the telescope. Little more than 5 years after the appearance of Kepler's nova, Galileo first turned his tiny optic tube to the skies and found that he could see stars so faint that they were quite invisible to the naked eye. However, no novas were seen for many years, and it is a fact that the stars of 1572 and 1604 were much more brilliant than any which have appeared since. Only during the last 100 years has it become plain that novae are by no means as rare as it used to be thought. Few become bright enough to be seen without a telescope, but fainter examples are relatively commonplace. In 1936 there were no less than 4, 2 in Aquila the Eagle, 1 in Sagittarius, and 1 in Lacerta the Lizard, close to the Great Bear. Of these, only Nova Lacerta was conspicuous. At its brightest, it surpassed Polaris, but it faded quickly. Nova Persei 1901 reached a maximum magnitude of +0.2, the brightest nova of modern times. After fading into obscurity at about magnitude 12, during the early 20th century, Nova Persei began displaying infrequent outbursts of 2 to 3 magnitudes. It was then designated a variable star, GK Persei. Since about 1980, these outbursts have become quite regular, typically lasting between 2 months and occurring about every 3 years. Thus, Nova Persei seems to have changed from a classical nova to something resembling a typical dwarf nova type star. Nova Cygni 1975, or V1500 to give it its official title, was a bright nova occurring in the constellation of Cygnus the Swan. It had the second highest intrinsic brightness of any nova of the 20th century. Nova Cygni was discovered on August the 29th and reached magnitude +1.7 on the next day. It was first recorded by the Japanese astronomer Honda. It remained visible to a naked eye for about a week, and 680 days after maximum, the star had dimmed by 12.5 magnitudes. It reached its peak of magnitude plus 1.8 on the 30th of August, below plus 3 on the 1st of September, below plus 4 the following night, and below plus 6 by 7th of September. I remember it as a very red star looking like a glowing coal. When a supernova occurs, it sterilizes the region of space around its setting due to the vast temperatures and velocity of its exploding debris. At the same time, the star disperses heavy elements cooked inside its stellar shell, which allows new stars and perhaps life to form. We are all star children in a way, since the elements that make up our planet and life in general were once part of a supernova explosion before the formation of our solar system 4.5 billion years ago. That's all we have time for this month. Please visit our website, where you can watch all of the past shows of astronomy in space, and if you like this programme, please share it with your friends and members of your local astronomical society. Our next programme will be available to watch from March the 31st, so please make a note in your diary. Until then, goodbye for now. And the nearest of the stars, Proxima Centauri, is 24 million miles out. Figures on this scale are exceptional, so astronomers have introduced a yardstick we call the light year. It is based on the velocity of light, which amounts to 186,000 miles per second, and which has been measured with great precision. If a ray of light covers 186,000 miles each second, it will travel roughly 5,880 trillion miles. That's almost 6 million miles in a year. This is the astronomer's light year, so that to convert light years to miles in round numbers, all that you need to do is multiply by 6 million. In metric unit, it amounts to 9.5 trillion kilometres. On this scale, the nearest galaxy, Messier 31 in the constellation of Andromeda, lies 2.2 million light years distant. The star's magnitude is a measure of the star's apparent brightness. The lower the magnitude, the brighter the star. The unaided eye can see Danube in Cygnus, the swan, and Altair in Aquila, the eagle. Delphinus is recognisable as a small haze of faint stars not far from Altair. Members of the American Association of Variable Star Observers then set to work observing Nova Delphini on every available night. Its magnitude slowly fluctuated over time, however it was clearly in decline, reaching magnitude plus 6 on August the 28th and plus 9 on October the 10th. The nova is now coming into view in the morning sky and was last observed to be around magnitude plus 12. A careful search of photographic plates in the Asiago Plate Archive found what is now believed to be the original white dwarf star that exploded at Nova Delphinus 2013, which was shining at magnitude plus 17. Ulysses Morori and Arne Hendon of the Concoli Observatory, Budapest, said that the spectrum and variability of the star are in agreement with a white dwarf dominated by the emitting stars down to magnitude plus 6, and the world's largest telescopes will show stars of magnitude plus 24. Bodies can be brighter than plus 0.0. The planet Venus can reach minus 4.4, while Jupiter is currently shining at magnitude minus 2.1. Therefore, when a nova reaches naked eye visibility, it is a special event. Nova Delphini was discovered by Koichi Itagaki In Japan on the night of August the 14th, 2013, shining at magnitude plus 6.8. It had turned over a few days previous and was getting intrinsically brighter by the hour, reaching maximum magnitude of plus 4.8 on the night of August the 17th, when it was visible to the naked eye. The following day it was officially classified as Nova Del 2013. It is known as Nova Delphini because it lies in the little constellation of Delphinus, the dolphin. The best direction finders are the three brilliant stars of the so-called summer triangle. Vega and Lyra, the Lyra. Nova is not a new star at all. What happens is that a formerly very faint star suffers an outburst which makes it flare up many times its normal brilliance. It remains bright for a few days, weeks or perhaps months, and then sinks back to its former obscurity. In the past, there has been some spectacular nova. Most have left fingerprints in the form of nova remnants, which astronomers are studying in great detail. Take a look at these two photographs. The Crab Nebula, Messier 1, in the constellation of Taurus the Bull, is the result of a daylight nova that erupted in the year 1054. And here is a view of 3C10, the remains of a nova first observed by Danish astronomer Tycho Brahe in 1572, known as Tycho star. I'll have more to say about these historic supernovae later in the programme. Just as the solar system is a minor part of our galaxy is only a minor part of the whole universe. Our Earth is 93 million miles away from the Sun. Good evening. Thank you for following me on Twitter. I'd also like to welcome everyone who has joined me over the past month. Over the last 6 months, there have been 3 reasonably bright supernovae on view for amateur astronomers. 2 in our own Milky Way galaxy, Nova Delphini and Nova Centauri, which were easily visible to the naked eye, and 1 in the nearby galaxy Messier 82, which reached magnitude plus 10. Therefore, in this month's programme, we take a look at supernova. The word nova is a Latin word that literally means new, as in new star. Strictly speaking, a